All right, the first question from your practice test I want to look at. There's a couple items on this question that will help us to solve this quickly and rapidly. One of the big things we're going to be doing in this class is looking at ways to simplify or looking at keywords to help us work through these problems quickly. The key in this problem is this phrase right here, straight line. If you remember from Algebra 1, the most basic and easiest equation to use for a straight line would be this one right here, y equals mx plus b. Remember that equations of lines typically involve y and x. The things we need to figure out for equation of a line would be our slope and our y-intercept. So the first thing we have to figure out is the slope, which is your rate. If you remember the formula for slope, we know that for slope we subtract the y's on top and subtract the x's on bottom. So using these 2 points right here, I'm going to subtract the y values. That would be 14 minus 20 on top, and on bottom we're going to take 0 minus 1. In doing so, you end up with -6 over -1. So the slope or the rate of change here is 6. Now that we have rate, we know that our equation must have a slope or a rate value equal to 6. At this point in this problem, I would look at process of elimination. If you look at the equations here, we know we want something in this form, y equals mx plus b, which would also be distance equals rate times time, plus this is our y-intercept or starting point. So now that we know the rate is 6, we can eliminate this. The rate here would be 34, the rate here would be 14, the rate here would be 1. So we're down to 2 options. Very quickly using our chart, we realize that at time 0, our initial starting distance was 14. So this 14 is your y-intercept, it's the value at 0. So this particular equation would be distance equals 6 times t, your rate of 6 miles an hour, times the time plus 14, and the 14 is the distance we had already covered when we started our stopwatch. So the answer is C. The next question I'd like to look at is number 15. This question was often missed on our practice exam. I just kind of want to review systems of equations and the best way to go about solving this. My hint here is that based on the number of unknowns you have in a problem, the number of unknowns will determine or dictate how many equations you have. So in this case, we have 2 sizes right here. We're trying to figure out how many of each. So we don't know how many of the small, how many of the large. So we have 2 unknowns. With 2 unknowns, you must have 2 equations to solve. That's just kind of a general rule. If we had 3 unknowns, we would need 3 equations, etc. So the 2 unknowns we have are the amount of small figurines. I'm going to let x equal the number of small we sell. And for simplicity's sake, we're going to let y equal the number of large. One equation is quite simple. We sold 70 figurines, so we know that the number of small figurines, x, plus the number of large figurines, y, has to equal 70. The second equation we're going to come up with is going to be based on cost. It says the large figurines sold for 12, so we're going to have $12 for each large figurine, which is y, and we're going to have $8 for each small figurine, which is x. Now, in this case, it says the amount of money received from the sales was equal. So in this case, maybe I shouldn't use, or I definitely should not use plus. I know that the sales for the large, which is 12y, has to equal the sales from the small. And that comes from that keyword right there. So now we have 2 equations, 2 unknowns. We have different processes for solving these equations. I guess my advice would be to use substitution when possible. I need to solve one of these equations for x or y. So I'm going to take this equation and get x by itself. I could subtract y from both sides here and end up with x equals 70 minus y. We can then use substitution by taking this and plugging it back in for x right there. So the equation we're looking at solving is 12y equals 8 times 70 minus y. And this right here is what x was equal to from our substitution right there. So we have the distributive property, 12y equals 8 times 70 is 560 minus y. We'll add y to both sides. We get 13y equals 560. You'll see right here I made a mistake. When we distribute, we have 8 times 70 is 560, and 8 times negative y should be minus 8y. So to solve this, we're going to add 8y to both sides. We don't end up with this mess over here. We end up instead with 12 plus 8 is 20. Y equals 560.